Let's see if it's worked. Okay. We're going to have 2 sessions today about Spring Boot. One of them will be imparted by Philip Riecks, and the second one, the first one will be by Daniel Medina and Guillermo Mazzola, and the second one will be from Philip Riecks. So we have today's our Master of Ceremony is Bruno Romao, but before he starts, I'm going to ask you, do you know what is the Barcelona Java Users Group? Raise your hand if you know it. Okay, there are many people who doesn't know. So it's time for the introduction, Bruno.
Okay, so we are a non-profitable organization with more than 2,300 people since 2012, and we are a bunch of guys enthusiasts in technology, not only Java, but everything related to technology, like Kubernetes and so on. We are open to discuss any new technology like AI, Spring Boot, Quarkus, and so on. So we are curious about technology. How many of you have been in a meetup before from Barcelona Juke? Okay. Who is here for the first time? So we have a lot of guys here. Okay. So what we do, like we said, we prepare meetups like this one, where we discuss frameworks. Like today we're going to discuss about Spring Boot. We discuss about architecture, and normally we do this kind of meetup twice a month. We evaluate and share ideas, and we try to help the community to grow up. And everything that's related to Java. This is what we do. Just to let you know, we are moving to Luna. Nowadays, we are in the meetup, but we are migrated to Luna. And if you want to subscribe, please take a photo from our QR code. Then you can take notes from the next events and so on. Okay, the WhatsApp as well. If you subscribe in the Luma, there is a feature that every event that you subscribe, you are going to receive a notification in your WhatsApp. This is a feature that you have in the Luma, but we don't have this, for instance, in the meetup. That's a nice feature, yeah. So if you want to follow us, we have others sites. For instance, we have a new website. If you want to take a look, we are on Twitter. We are on the YouTube as well. In the YouTube, you can check the previous events that you have presented. We are in the LinkedIn now in Luma and in the Flickr as well. Oh, really? Nice, nice. Nice. Okay, like we said, we are a non-profitable organization, and we are in Open Collective. In there, you can subscribe and to contribute to us to prepare like these events and others. So if you want to contribute, here we have the QR code. You can take a photo and subscribe them. Okay. So here we have a list of some past events. So like I said, we have some events about Spring, Kubernetes, Quarkus, Docker, and so on. Test containers and AI as well. No? So the next events, we have the open space, where we're going to celebrate the 13 years of Java in July. June, no? Probably, yeah. We don't have the data yet, but if you follow us in our networks, you let you know. Okay, how many of you know what is the DevBCN? For the people that doesn't know, DevBCN is a conference that is going to happen. Well, it happens every year. It's gonna be the 31 or the July 8, no? Yeah. So we have here a QR code with discount, 20% of discount if you want to participate. In this event, we have not only Java, we'll talk about Kubernetes, AI, what else? We'll talk about everything related to technology. There are 5 tracks, correct? They'll be here.
They are, sorry, they are Java champions and developer experts from Google, representative, top representative from the industry, and this is your opportunity to learn from there and interact with them as well. So it's a good opportunity. It's a 20% discount for you only.
If you want, here you have the QR code and you can take a photo to get the discount. So thanks for Glovo to prepare this space for us and to give a talk for us as well. And for IntelliJ to provide some license. No, I don't know if you have some license.
Yeah, we have a partnership with JetBrains. So if you are interested in a license of maybe idea, you can talk to us. We can make it for you.
You can give some IntelliJ license for free. And the next talk is from Glovo. Okay, thanks.
Okay, the clicker, you have it. Perfect. Okay, hello everyone. I am Eduardo Costa, Senior Principal Engineer here at Glovo. I will not be giving the talk. I'm just going to present the company and the people giving the talk. So Glovo, for those who hasn't used Glovo ever, has everyone used Glovo? Everyone is lives here. Everyone used Glovo at least once. Okay, amazing. Then yeah, this is going to be boring for you. We're building the largest marketplace in your city to give you access to anything in minutes. We operate in 23 countries, more than 1,500 cities, and we have 150K partners, essentially restaurants, supermarkets, etc. How big is technology at Glovo? We consider tech to be product, engineering, data, and UX. We have 10 different clusters, around 75 teams, and 500 employees across all of those layers of the organization. Everyone here in Barcelona. And yeah, of course, I couldn't not say that we're hiring and that we give quite a lot of meetups here in this office, around 1 meetup per month. So please feel free to scan. Even if you're not interested of changing job, you can refer someone, so please scan. More phones, come on. And yeah, with that, I'll present the presenters. We have Daniel Medina, he's a staff engineer at the SRE team, and Guillermo Mazzola, he's a staff mobile engineer at the platform team, at the mobile platform team. They'll both tell us about the journey that Glovo went through to migrate our fleet of microservices from Spring Boot 2 to Spring Boot 3, and the challenges that came from that and how we solved them. So yeah, give a round of applause to them.
Thank you, Edu. So yeah, we will be presenting the, I think, rather original solution for a problem that is probably shared across many organizations of our scale. Different companies have different solutions. We decided to go to the magical one. So yeah, to give you a bit of context of what we will be covering today, I will explain what really is our problem, what the scale brought to us in this matter, and how the migration to Spring Boot 3 at some moments looked almost impossible until we were able to break it down into smaller steps. So this problem that we had starts from our scale. In Glovo, we have around 200 microservices for our backend. They have completely different varied sizes and complexity. Some of them have just a couple of consumers and a couple of endpoints, whereas others have hundreds of endpoints and run in massive containers that really represent a big portion of our complexity as a company. Other than this, we also have a central JVM kit which is essentially a set of libraries through which mostly the SRE team, but other infrastructure teams as well, offer some centralized solutions for problems like observability or event consumption or concurrency or some central things that we wanted to standardize to minimize the barrier to cross-contribute across different teams. And on top of that, we also have some of these 200 services that offer SDKs that are published with the same dependency set as that service itself, which abstract either the client to connect to this API that is served by the service or expose some business logic that we want to be shared about across different services. Things that have to do with validation of some emails in this case, or some validation of user input, or things like that have to do specifically with one domain in or one team and wants to be shared across different services. So this JVM kit provides this standard experience for the developers within Glovo, but at the same time, when on the maintenance side, means that it has to be compatible with the oldest service in Glovo. But we also want it to evolve to adopt the newest standards. So we have to kind of compromise and make sure that every decision that we make will not impose a big effort for the teams to adopt it. So this means that if we want to maintain our contract of backwards compatibility, if we bump any transient dependencies for big frameworks, in this case, for example, Spring Boot, but not only, they must align as well to the semantic conversions of the JVM kit. So if there's a major upgrade of one framework like this, we also have to issue a new major version of the JVM kit itself. So this seems to be like we cannot really bump from Spring Boot 2 to 3 without compromising this contract, or we would need to at least make it very hard for users to adopt this new version of the JVM kit if they have to do both migrations at the same time, migrating to the new version of the JVM kit at the same time that they have to migrate from Spring Boot 2 to Spring Boot 3. That would be a very big change that has proven very, very hard. So we started exploring our options. The first obvious option was just to make this breaking change and just like say, okay, that's life. That's what you have to do. If you want to adopt the newest version of the JVM kit, you will have to make this effort in your service and upgrade everything at once. The JVM kit, Spring Boot, and everything that is associated with it. The pro is obvious. For maintenance, this is great for us as a maintenance of the JVM kit. The cons is that not only it's a very big migration effort, but also this translates or translates the problem to SDKs that are published by the services as well. Meaning that if I am service A and I expose my SDK that is also using the JVM kit and is also using Spring Boot, and I bump my service to Spring Boot 3, it means that my SDK will also bump to Spring Boot 3, which means that any consumers of my SDKs, either they bump at the same time that I do, or they stop getting support from my SDK. So it's a big problem for them as well. The second option that we explored was, okay, let's try and separate these two migrations, the JVM kit version 6 versus the adoption of Spring Boot 3. We can do this in a way that we copy and paste our code, the same JVM kit code that we have, completely in two branches of our repository. And one branch will be compatible with Spring Boot 2, and the other one will be compatible with Spring Boot 3. It kind of simplifies the issue of bumping one specific service from from Spring Boot 2 to Spring Boot 3 because it decouples the two migrations, but it doesn't solve the issue of the transient, the inheritance of the problem to SDKs. So if I am exposing an SDK, my service will be either in Spring Boot 2 or Spring Boot 3, but it cannot be at both at the same time because I will be using one of the two dependencies. So this still doesn't solve the issue because every SDK would also need to copy and paste their code. So the only available option was magic. We had to call our magician of choice and tell them that we needed a way to use the same code base, maintain a single code base with everything that is in common because the JVM kit is not really impacted by the Spring Boot 2 to 3 changes. But from there, publish a version of the code that is compatible with both Spring Boot 2 and Spring Boot 3. That means that the SDKs can also do the same, dual publish their artifacts with the same mechanism, and issue an SDK that is compatible with both Spring Boot 2 and Spring Boot 3. As long as you are in JVM Kit v6, you should be able to do that. So that's what we did. We called our magician Edu, and we called our magician Guilla, and we said, you have to fix this. So let's see how they did it. Oh, we did it.
Thank you, Danny. Well, first, maybe you will be wondering why a mobile engineer is involved in all of this. The reason is Android builds on Gradle, and I like to research a lot, so I'm also some kind of the guy that has more knowledge on Gradle. So it was the right candidate to do this. So undertaking the solution, this is what Danny introduced, the proposal that they want to build, the requirements, and this is what we came up. So basically build something, probably using Gradle, that it will publish 3 artifacts. One with common code. This means code that can run perfectly on Spring Boot 2 or Spring Boot 3, and then a companion artifact depending on the task set that you want to consume. Or, for instance, Danny mentioned the Shabak Jakarta incompatibility. So if you have the same class that needs to import one class or the other, we'll have the same class in one of these two. The combination of two will be the jurisdiction. We produce an artifact that it will be replace the old one. Okay, so this is more or less the requirements that we put in the solution. The first one we covered already. Basically, we want to have gradual adoption because the scale of Glovo and the complexity that I have at the SDK, depending on another SDK or on the library, and we want to allow the teams to gradually adopt it. The second one is more the focus of platform, that build tool that doesn't require or translate the complexity to the users. So we want to abstract because all of this from the users for making them simpler to adopt because they have already a complex task, which is migrating from Spring and Shaving Kit, to put on top of that to also prepare your project or build script to use it. And the third one is an important one, actually saved us already a couple of times, that we also want to prevent errors from configuration. And by errors, I mean that maybe you are putting the Spring Boot 3 dependency of the Shaving Kit or any SDK that we have, but transitively you have consuming another one that is transitively using an older version of Shaving Kit, and all of that will end up that in your class part you have classes from Spring Boot 2 and Spring Boot 3, and that's a problem. So we also want to cover that, and the solution is something that I wanted to introduce because I'm not sure that anyone or most people is aware of this, and for us it was also mind-blowing at some point, and until we got it. I actually finished got it this morning, to be honest, after I built all the stuff. Which is a great capabilities. It's a feature from Gradle. Most people will know Gradle as they know Maven. That's just a tool for resolving dependencies. Gradle is a bit more complex than that. One of the features that it has is capabilities. And basically, what it does is to enrich. You might notice if you consume any dependency built by Gradle that it's not just the POM anymore. They also have published a metadata artifact plus the artifact, and also metadata, which is an enrichment of metadata on top of the POM. One of that metadata is the capabilities of the dependency. What is a capability? Basically is I have a dependency that provides this feature. It's an abstract name. The capability is just another, like a coordinating Maven. It's just a group and an ID. But the thing is, Gradle builds on top of that if you declare that the dependency has a capability, you cannot have another dependency, wherever it came from, with the same capability. If you have that condition, then the build fails on resolving the dependencies. This is for us was not the critical thing that we wanted to cover. Another concept regarding capabilities is that by default, when you declare a capability dependency on Maven, there is and you never mentioned never saw the concept of capabilities because the capability is there and it's implicit. The implicit capability of the dependency is basically the dependency's coordinates. So if you declare Shell unit, whatever version, you are sort of declaring that you are consuming the capability Shell unit is provided by the dependency. Unless the dependency says otherwise, that will be the one. That's it. I think from capability, I don't know if this clear, but we will make over that with questions later. But basically, just remember this. We use this to facilitate to have a healthy class path. So if we have this, then transitively, you cannot have the same, even if it's another version. Okay, going into details, the solution. This is what I was called for. Two great plugins, my expertise right now. The first one is the more complex, and is what we call the producer plugin. Basically, any library or SDK that wants to have this dual behavior. By dual behavior, I mean, let me go back. I mean this, like a share code in the source set, code dedicated to one Spring version in another source set, and code dedicated to the other version in another, and the three of them getting published in this way that you can consume it is what we call dual behavior. So the producers is the Gradle plugin that builds on that applies on top of the Java one and wires your whole Gradle project to achieve this. And then we also create the consumer plugin, which is meant for end users. Could be your application or could be a library that decides, I'm not going to do dual, I'm just going to do the bump. So I can apply the consumer plugin there, and my outcome of my library will be, I just support Spring Boot 3. So we have these two plugins, and the two of them have to work together. I'm going to explain how they work later. Next slide. So the consumer plugin. I start with the easy one. Basically, you apply it, then the DSL or the build script gets enriched with this Spring version DSL, and you have basically two options there to tell I'm going to use Spring Boot 2 or I'm going to use Spring Boot 3, and that's it. Once you apply in, it hooks on the dependency resolution and decorates all the dependencies that you had that by requesting the capability of Spring Boot 2 or Spring Boot 3. So if you remember previously, I mentioned that capability is something that decorates the dependency, that you can say this dependency provides, in this case, compatibility with Spring Boot 2, but it could provide an concrete implementation of a database. It's abstract. You declare in your build or how it works. So basically it's that. You apply the plugin in your project and you say, I'm touching this, Spring Boot 2, I bump the JVM kit because I cannot use it if I don't apply the plugin to the version 6. I do I address the breaking changes of that migration, and then in another PR, I can say, okay, I'm gonna touch Spring 3 and I'm gonna address the breaking changes of Spring 3. And this way I can do it gradually. I don't know if it's clear, but let's talk about it. So the producer, this is a bit more complicated. We build on top of another feature of Gradle, which is feature variants. And we are not using it right away how it's meant to be used, because we hack it to support this because it's a use case that they don't support or they didn't thought about it, but we use it because it saves a lot of wiring and a lot of scripting and on the plugin. So basically, a feature variant on Gradle is like, I don't know if someone of you has used text features, the plugin, Java, but it's basically the same. It actually is built on this on one of these feature variants. You can declare in your same module, you have your main module, and you can declare a secondary module that's gonna be on the same coordinates of your, when it's published on the same coordinates of your library, but you can consume it by requesting a specific capability. So if you use text features, sometimes it's the same. Text features is actually a feature variant called text features. So we build on top of that, we created 2 feature variants, Spring Boot 2, Spring Boot 3, and then we define in the concept that the main sources is gonna become the common sources that we talk about. So after all of this, what we have to do, you have to split your code into what requires changes, goes into Spring Boot 2 or Spring Boot 3. Or basically, if I migrate to 2 and 3, I move the code that doesn't require changes to common, the code that requires changes to Spring Boot 2, and then I implement the same class with Spring Boot 3 in the other subset. What else? For all of this, we have tests and stuff. I'm gonna skip it because otherwise it's too much information. But then the important thing here is that each variant, as I mentioned before, will provide a dedicated Gradle capability. So if I want to target Spring Boot 2, I will say require the capability Spring Boot 2, which is done by the consumer plugin. You don't need to do it yourself, so it's transported for you. But the important thing here is that for both of them, we also declare the shared capability. So each one of the artifacts will have a common capability, and this is critical for us because that common capability, which is basically the same on both, will prevent that you accidentally have the two versions of the library in the class path. If you have two versions, one, let's say directly, I bump to Spring Boot 3, but I have another dependency that is still using Spring Boot 2, it will break. Because at the end, when I resolve the whole class path, I will have both capabilities conflicting in the class path. And we choose as that shared capability to be the implicit one to cover even more cases, because the implicit one is gonna match to the capability that this was coming from the previous version that doesn't have the dual behavior. If you remember, the implicit one is that the one that Gradle adds to any dependency. So we choose the same one after a lot of try and error. It was not straightforward. We choose to do that, which is not allowed by Gradle. This is the hacking part. We need to hack it to make it happen, but we could. To publish an artifact that has the two capabilities, the default one and the one that we want to query. I don't know if there is, no, that's it, more or less, very high level of what we have built. And recapping the original requirements that we put on the solution is this: the scalability we achieve it by, as we said, with enabling the dual behavior, and that the project can initially target just the Spring Boot 2 and do the address the breaking changes of bump in the JVM kit library. And then when you are ready, in another PR, you can target Spring Boot 3 and address the breaking changes of Spring Boot in this case. Quick setup. I think we didn't get much feedback myself, but I think it's more or less easy. So for the consumer, it's just applying, it's just add one line in the build script and that's it. You get it done. And for the consumers, it's also easy because you don't need to modify your whole build script in your project. Just need a plugin. The complexity is the work that you need to do after, which is not solved automatically. You need to do it, like adapting the classes, splitting them into common or particular, or whatever. And the third one is also achieved because with the Gradle capabilities, that basically what I explained before, if you have transitively, which happens us a lot, and we didn't realize until we see the error that it was happening. If you have, for some chance, Spring Boot 2 or 3 or JVM Kit 5 and 6, basically you cannot compile the project, it won't run because it's telling you that it has conflict capabilities. And I think that's all. Yep, and I say capability a lot.
Okay. Okay, thank you very much, guys. Maybe if anyone has a question, we can take a couple of minutes to answer them. Any question from anyone? You can ask what's a capability again, because
So essentially you have two sources, right? A and B, and each of them are implementing stuff specific to Spring Boot 2 and Spring Boot 3. Let's say that for those implementations, we need several set of other dependencies. In each of them, it means that the final artifact for this SDK will require the sum of all of these dependencies in each source set, or is it, how does that work?
Very good question. So the class paths of each of the variants are built independently, which means that the common source set will have some dependencies that are required just for the common one. Those are shared between the two variants, but then the things that are specific to Spring Boot 2 or Spring Boot 3 are declared as specific dependencies for the Spring Boot 2 or the Spring 3 variants. Other than the classic implementation or API or test implementation and test API, we added some more DSL that allows you to say, okay, I have a dependency that is only for Spring 5 or Spring Boot 2, which means that I can say Spring 5 implementation, or I mean, we call it Spring 5 because Spring 5 is the one that goes with Spring Boot 2 and Spring 6 is the one that goes with Spring Boot 3, right? So you can say Spring 5 implementation, the name of the dependency, and that will go only to the artifact that is built for the variant for the Spring Boot 2. And the same goes for the Spring Boot 2 and also for the test scopes, because the tests are so separate. So you have the DSL for just that. Does that answer the question?
Just one comment. There are three sources: the common, the main one, and the other two, and the rest is what. All of these we didn't do it. It's just provided by the Gradle feature variant. That's why we use it. This configuration that then is explained is done automatic. It's done by Gradle, not by us. We just build on top of that.
I have a question. So your only task was to develop this plugin, and then the value stream teams were in charge of implementing it.
Well, he that was his task, building the plugins. Between the three of us, mostly what we did was adapting the source code of the JVM kit to use this publishing plugin, and also provide feedback about the plugins, especially for the consumption side. And then the service owners are the ones responsible for using the consumption plugin to bring the JVM kit v6 into the class path.
Okay. Now my question is, did something to encourage that for teams to adopt the new Spring Boot version? Do you have like a time constraint or something? Because as being this like a pool-based system, and the teams having the priority of delivering more feature, we don't have time for resolving technical debt. What did you do to encourage the adoption of this?
I have never heard of that problem. No, very interesting question indeed. This is the modernization of the Java stack, or the global tech stack is a priority for Glovo. So it is tied to company level OKRs, and that's how you gain push for these kind of initiatives. But yeah, it's a tremendous problem that we suffer continuously. Of course, this healthy tension between working on the maintenance of services versus working on the development of new product features. But yeah, it goes to this company level key results that are tracked and in the end impact everyone's performance.
Well, just to comment in our side, we had the same situation. We faced the same challenge. In our case, what we did was building a small team of enablers, and this team was in charge of touching every microservices and do the migration because the business teams were very busy.
Yes, super good initiative as well. We did a kind of similar thing. We selected what we call champions for every one of the clusters that Edu presented in the beginning. And those champions are meant to be responsible for the progress in their cluster of the migration to JVM Kit 6 and the adoption of the Spring Boot 3. one person for the whole cluster, given the size of the clusters, was really not enough. So we have seen how several clusters, for example, FinTech, has been driven their own initiatives within the cluster to promote further down-level champions, so that they have champions per team that are kind of pushing, or specific people that are pushing for these efforts internally, so that the knowledge can be spread across everyone. In the end, all service owners need to be aware of this process, because otherwise it gets counterintuitive to maintain a service that you don't really understand. So we really need the involvement of all the service owners, and not just the selected champions, for this to really work in the long term. But yeah, so far that's how we've been trying to do it, through encouragement and trying to give incentives, and with the push of leadership with these OKRs. But yeah, the timelines is probably the trickiest part of it.
Okay, any other question? Last question, then you can pick their brains over pizza.
Thank you. My name is Nikolai. My question is, so now when you have two different versions supported, you also need to make sure that business logic is also working with both of them, right? So if you have some functionality or some libraries that are supported or changed over different Spring Boot versions, do you ask developers to implement different business logic for both versions, or how do you ensure that over time they both are supported?
Business logic doesn't live within the JVM kit, because the JVM kit is kind of a platform tool that aims to be as business agnostic as possible. This is not always possible, but it's kind of the general norm. Where this issue that you're raising is relevant is for the SDKs that we've said before. In this case, well, is the task of the service owner or the SDK owners of that functionality to use the dual publishing mechanism that we exposed, so that they can make sure that both of the variants, both of the Spring Boot 2 or the Spring Boot 3 versions, are compatible with or that are working properly. Since the tests are also split between the two, they can test the functionality in both versions independently. They can also have tests that are common but are running against the two different versions. They will run twice. They will run once with the Spring Boot 2 version and one with the Spring 3 version, so that they can make sure that the same quality standards are applied to both versions. But it's in the end the responsibility of the person maintaining the code to ensure the compatibility.
Okay, thank you very much, guys.
Thank you.
Hello. We are not going to have a break, but instead we are going to jump right ahead to Philip Riecks' talk. He is going to talk about demystifying Spring Boot applications, right? Cool. So the stage is yours. No, no break. Only when you finish. So pizzas are getting cold. No pressure.
No pressure. Test, test, test.
You can play this at the end of the set, or you can play this very early in the morning.
Can you let me in, please? In the Zoom? Test, test, test. Working? Perfect. So thank you very much for coming to my talk, Testing Spring Boot Applications Demystified. I want to start with two questions. Who of you in the audience is still writing manual tests for the application despite having LLM tools at their hand, like, I don't know, JetGPT, Claude, or JetBrains Juni? Okay, that's, I would say 70%. And who of those audience still enjoys writing unit tests? Okay, even less people, so I guess 20 persons, 20% of the audience. That's perfect that you're here. So I like to share some real-world best practices, common pitfalls, and strategies when it comes to automated testing of Spring Boot applications. I'd like to start with the way I got introduced to testing, because I guess it's similar for many people. So I studied business information technology. It's like 50% business and 50% computer science. And we learned about like TCP, IP, like operating system, what have you, software development, OOP patterns, UML diagrams, but really never automated testing. Quite late into our studies, we had one practical exam where we had to develop a Java application with Java Swing, so a desktop UI application, where we had to develop like a company decision-making game. So you're a company and you have to decide, do I extend to region A or B, or do I develop product A or B? And learn how UI development works with Swing. And one of the requirements to pass the test or the class was to have some automated tests. So it was written in the requirements. And we happily accepted this on the first day, then gathered together in a group of 5, happily developed the application. And then one day before submitting the source, we rechecked our requirements and saw that there was one requirement we haven't touched yet, which was automated testing. Nobody of us knew how to do it, so we figured out what to do. We threw in JUnit, did some Mockito, but really, just threw in annotations, called our classes, never did any assertions or verifications, just to have some classes in source test Java to pass the exam. And lucky us, the teacher seemed to not care about the actual quality of tests, just the existence of tests. So yeah, we passed this. I passed the university, but really never, or for at least for me, nobody taught me how automated testing works. And this then continued at my first job. So being a junior developer, joining the team, you're quite eager to take your first Jira ticket, develop a feature, like show that you have skills. You tackle the first challenge of setting up Java, your IDE and the project, and then I picked the task, developed it, took quite a week, and then when I raised the pull request, the answer I somehow got, similar to this, from the tech lead when I submitted the feature, was that he was complaining that there were no tests written. And I was wondering, I looked back in the Jira ticket, there was no requirement that we had to write automated tests, but apparently there's a definition of done, and I learned about this the hard way. So I went back, asked the lead developer how to write automated tests, and he said, just look at the rest and adopt. So there was also no real education for me when it comes to automated testing. It was like cargo cult, doing the same over and over for years. Until some years ago when I tried to really get my hands on automated testing, because I thought like there's not much good or quality content out there. At conferences, you hear about AI and cool features, but nobody talks about testing usually, but we all have to do it. So that's why, I kind of doubled down on this automated testing with Spring Boot niche for myself. And with this talk today, I want to give you at least the foundation of what I wish I knew when I started with writing automated tests for Spring Boot applications. We will do an introduction to what I think is an excellent test support, what we get with Spring Boot. And at the end, I will showcase a mix of best practices and early pitfalls for you to not tap in. And last but not least, what I try to do with all the content I do and the courses is like to teach more developers that testing is not an afterthought. So usually something you shouldn't neglect, or just spend 5% of your time on it and just copy paste stuff from your other tests. Some words about me. So I'm Philipp. I'm from Germany, Herzogenaurach. It's a small town next to Nuremberg, Bavaria. We have the headquarters of Adidas and Puma. So small town, but worldwide impact. I've done some blogging and content creation now for almost 5 years. At the beginning, I started to blog about what I learned as a junior developer, what I couldn't get my head around, for example, like dependency injection, starting with Java EE back then and CDI. I had no clue what I was doing, also throwing annotations at getter, setter, constructor, fields. I don't know. What started with this blogging became more in a focus on Java and automated testing with Spring Boot. With my company, we help developers and teams to deliver software with more confidence and more frequently. So it's not just testing. So all the testing we do has a cause to move fast, break things, and detect this hopefully more early than the customer. Yes, so that's about me. For the agenda for today, we just finished the introduction. I will follow with the big block about testing Spring Boot applications, 4 parts. First, the basics about Spring Boot testing, then unit testing, slice testing, integration testing, and then, as mentioned, best practices and pitfalls, and finally, summary and outlook for you to show what's also possible with AI and agentic tools that can help you with automated testing. So for the basics, usually when I go to teams and we talk about writing automated tests, there are naming issues. So everyone in the team names things differently. So for the one person, a unit test is called fast test because he or she read software engineering at Google, adopts the naming patterns to their work. We have many different kinds of testing that all have their purpose and usually are present in academia. And when I come to teams, I usually boil it down, or for me, I try to be as pragmatic as possible because I don't want to spend 2 or 3 hours discussing if this is a unit or integration test. I would first like to lay out some ground rules for at least the team, better the company, how testing is tackled, or at least we have the same naming things. So for me, it starts with a unit test. Usually unit test something that tests something in isolation, usually a public method of a class. It mocks external collaborators. So if it uses the help of other classes, they are usually mocked. So it doesn't touch any network traffic. It doesn't need a database, and usually, maybe writes to file system, but at least it's testing one small unit in isolation and not many things together. What follows integration tests? So they are now testing at least 2 things together, usually with some infrastructure components. So we later see when we test our repositories with data JPA, they need a database, so a little bit more sophisticated than a unit test. And last but not least, end-to-end test that really verify the application from a user's perspective. So if we have a checkout system that we really trigger and checkout flow from the UI through our backend with some final verifications, I don't know, in an email inbox that says order confirmed. So these are my my testing name methodology, and I will use it throughout the talk. We heard about Gradle, so I'm Maven advocate, but I hope some of you also use Maven because I want to start with when tests are executed, when we are using Maven as a build tool for our Spring Boot application. So the first plugin is the Maven Surefire plugin. This plugin will execute or is designed for running the unit tests, and this plugin detects a unit test with the postfix test. So if you have customer test, this plugin will collect all the classes and then hand over to the test framework. In the life cycle that you can see on the right, when we call Maven verify, these are the different phases that are sequentially executed. So we will first validate the project, then compile in the background. Java C compiles our Java files to bytecode. Then the test compile, we do the same for our tests. And afterwards, this test phase kicks in where the Surefire plugin runs our test. Afterwards follows package, so that we build the jar file. And what follows if we run verify and not package with Maven and configure it, so which is, I would say, the default pragmatic standard, we will have the Maven fail-safe plugin to run the integration test or also end-to-end test or any other more sophisticated test. And by default, it's detected with the postfix IT. So checkout IT can be configured. You can extend it, enrich it to your naming schemes, but that's the default that you get. And the reason to split it, so you could also say, why not run it with one shot? It's possible. Nobody will fail your build for you. But when it comes to parallelization, unit tests, depending on how you write them, are usually more easy to parallelize. And then if you have a split of those executions, you can have more fine-grained parallelization configurations. So you can say, Surefire, please do massive parallelization because you only run unit tests. There's no network, no file system, no database. Parallelize as much power as you have. Whereas for the integration test, you should maybe only run with 2 parallel integration tests and then in sequence in a test class. So this gives you a bit more configuration options when you start getting into test parallelization to fasten up your builds, to have faster feedbacks. Yeah, and overall, you can also better organize your tests, and you know that the test you're writing is now an integration test, and the other one was a unit test. Whenever there are questions, feel free. Not sure if you have a microphone to ask them right in between. Otherwise, we also have some time afterwards. What follows? There's a question.
I have one.
Yeah.
How do we make sure that the unit tests are not connecting to the network or?
So I guess technically there might be some hacky options. Usually I do this by education, and if this is a greenfield project and a new pull request, you have a review cycle and you say, hey, this is in our definition not a unit test. I guess there must be some, I'm not sure if with Wireshark or network access, you could technically cap this or run this on GitHub Actions or Jenkins in an isolated way.
I was going to mention that just run the test isolated way. Just disconnect your laptop from the network and run it, or run it in a machine that or in a container that not expose any connections outside.
Okay. So I'm not aware out of the box, but yeah. I would generally aim for to have like airplane mode safe tests. So if you're on the airplane and you pulled your Docker images and you run a compile before and have the Maven dependencies, that you're able to at least build and test your application. So this could be a metric you can aim for. Go on airplane mode on your device and then run the test and see if something still talks to Google or other services over the internet. Next, the Spring Boot starter test. So I guess here that's a really nice, convenient design decision of the Spring team. So whenever you start your new project at start.spring.io or any other way, and you select your dependencies and your database driver and whatnot, and create a project and then inspect your build.gradle or POM, you will see that there's one dependency, one starter that you didn't select, but the framework people put it in by default. That's the Spring Boot starter test. So I refer to the Spring Boot starter test as the testing Swiss Army knife, because when you start a new project, it really comes with batteries included. So no need to discuss which test framework you're using, with matchers, what matchers, and which version. It's a single dependency that transitively pulls many other dependencies. So the main dependencies, I guess most of you or us will use from a day-to-day basis is JUnit, Mockito, assert.j. Assert.j is a assertion library. And quite recently, they also added Avatility, which is a nice library for testing asynchronous code. So similar to other Spring Boot starters, Spring Boot takes also care of dependency management. So we don't have to think about bumping JUnit Jupyter. We get this out of the box. We bump Spring Boot, they bump JUnit Jupyter, make sure it aligns with the Maven plugins, with any other potential complexity, but in testing, it's not that complicated compared to their production libraries. We can also, if we have to stick to Spring Boot 2 for whatever reasons, we can also manually bump these versions like any other shared Spring Boot dependency. We quickly want to share this with you. Presentation mode. So imagine we are on Spring Boot 2 for whatever reasons, but we want to make use of the recent Mockito version because we need to stop static or final static methods or final classes, and our Mockito version is too low to have this feature. Then what I sometimes see in project that people then exclude the Mockito dependency from the Spring Boot starter test, but that's not necessary. We can simply override here the version if we know the dependency key, and then in the background Spring Boot will pick the right version, and we can also upgrade then if we have to stick to a not so recent Spring Boot version and can manage our Spring Boot dependencies, test dependencies. So that's not specific for testing, it's the same for any other managed Spring Boot library. To get to know the name of the key, so for Mockito it's quite simple, but there might be other libraries that Spring Boot manages for us that are not so simple. We can navigate to our parent POM, so when using Maven, go one hierarchy up and then one more. There's the Spring Boot dependencies project, and within here we will now, I guess, alphabetically sort it, or not so much because here's Zipkin, but nevertheless here we see the list that Spring Boot, what Spring Boot picks for dependency versions for us, and then we can search, for example, what is Selenium HTML unit, for example. Spring Boot would also manage dependency for us, and if we know this key, can copy this to our own project and then can upgrade or downgrade the versions if we need. Because when we run Maven dependency tree, so this command tells us which transitive dependencies are pulled by this Spring Boot starter test. We can see it's quite a lot. So first, the Spring test dependency, we have JSON path, which is quite convenient when verifying JSON data. It's a bit small. SRJ, assertion library, avatility as mentioned, Hemcrest, yet another assertion library. So you may ask why we have 3 assertion libraries. So JUnit comes with assertions, Hemcrest comes with assertions, and SRJ comes with assertions. Usually it's, pick whatever you prefer. I usually go with SRJ, and for Hemcrest there are some touch points with Spring Test where the methods are overloaded to take matches from Hemcrest, so you also need to learn a bit Hemcrest to work seamlessly with the Spring test classes. And yeah, but in general, pick one, stick to one at least for your project, because if you mix also the assertions within your project, developers might get confused, and it's not that convenient to then switch expected and actual in your assertions when you, for example, differentiate between Hemcrest and the JUnit Jupyter assertions. Bottom here, Mockito, JSON assert, yet another library for asserting JSON data, and on the bottom also XML unit if you still, or if you have endpoints that work with XML or do XML manipulation. So all of this comes out of the box, pulled to your project. There's also no issue because it's scoped as test, meaning it won't end up in your production jar. So your jar won't get bigger. So you might say, I don't need XML unit, should I exclude it? You could, but there's really no benefit as it doesn't pollute your production code. It's just another test dependency more into your project. When it comes to unit testing, some hints. So in general, with dependency injection, your business logic, your classes usually have public constructor where you pass the collaborating classes. So the dependency injection during runtime will pass an instance of a class. So this helps you then when you're doing unit tests that you can pass from the outside without any weird reflection, a mocked version of it that you can fully control with Mockito. When you try to test God classes, you will quickly see that your mocking setup really grows. So also this can be a good identifier that maybe your class is doing too much. So in general, develop small single responsibility classes that really, there is no strict rule, but 4 to 5, I would say, collaborating services that you're using might be a good rule of thumb. Test only the public API. So I would try to aim when doing unit tests, to verify the behavior of a method, not the implementation. So if you end up copy-pasting your implementation with Mockito, so you have a regex validation and then the same regex somehow is also in your test, that's not the way it should be. So really see it from the outside. I don't know what's going on internally. I don't know how many private methods are called. I'm just interested in the return type or any performed action of the small tested unit. And in general, test-driven development can really help here, because if you perform TDD, which is takes some bit of effort when you're starting with it, you will also get the feedback more early that what I'm trying to implement is super hard to verify. So I'm unable, because this grows in complexity. With TDD, you can then also reiterate, rethink, and refactor your code to maybe split out some logic into a new class method and then test this in isolation. A small hint when it comes to static methods. So at least the Java core classes sometimes work with static methods. So here, for example, Java time, the local date.now is a static method, or UUID works with static methods. If you now want to write a unit tests for this birthday service to verify if today is the birthday of the user, you somehow, or you may want to modify today within your test. So with the recent versions of Mockito, it's possible to mock static classes, static methods, or if you use PowerMock, it's also possible since years, but this gets quite fast, quite messy in the setup and a little bit more complex, I would say. In such cases, what can help is to rethink and then extract this, extract parts of the static class to a shared time util, or for example, in the case of when working with dates or time, the methods are usually overloaded that you can pass a clock. It's yet another Java class that represents your clock. You can pass it from the outside, and now having again a public constructor that really helps us during unit tests, because then we can pass a clock of a leap year 200 years ago from the outside, and then our test works with this setup. So it's much more simpler than to modify the internals to have the setup we want for our unit test. Yeah, that's now the test in action with using Mockito. Maybe too much cognitive load to easily grasp it, but just remember, whenever I can pass something from outside via the constructor, it usually helps to change the internals that I need if I want to test corner cases, for example. For unit tests, if or at least for my my definition, usually there is no Spring-related code, also Spring-related test code. So what I sometimes do, I check my imports. If there is a Spring extension or at Spring Boot test, I would not qualify this as a unit test. So taking a look at the imports and solely relying on JUnit, Mockito, and an assertion library could be a good rule of thumb to go forward. Test structure also quite interesting. So as I'm an independent consultant, I switch teams quite often. I see new code bases I have to adopt to the domain. What really helps if they write their tests in a manner that they act as a documentation. So if I then go to the checkout and take a look at the integration test, and then, if possible, read nice test method names that really tells me, I don't know, checkout from Estonia is not possible in a leap year because of regulation XYZ. I can really understand and get my hands toward the domain, and yeah, be much faster in the onboarding, because yeah, the code in the end is the single point of truth. Any comments in the code or yeah, any outdated Jira ticket might not reflect what's actually implemented. So with our tests, not only the unit tests, when we take a look at the test method, we can follow a structure that then helps also the reader, the reviewer, or a new person that gets onboarded to quickly grasp the tested behavior. For the test method name, we can follow, for example, given, when, then. So we can say what's our given state, when is what action are we performing. We are doing a checkout verification, then the expected outcome, user should be rejected. There are many other forms, but these are some you can follow within the test method itself. What also helps is if you structure it in 3 parts: arrange, act, assert. So you have an arrange step where you set up, for example, with Mockito collaborators, create test data. In the act part, you perform the actual, you call the public method, and in assert, you verify what happened. So, but unit testing has limits. So for example, if you have a web controller like a REST API and that returns users, and we only do unit testing, we can never be sure that the path is correct. We can never be sure that our Spring security rules are applied. So for example, everyone can read users, but only admins can delete users. So with just unit tests, like we saw it before, with JUnit, Mockito, and assertion libraries, it's almost impossible to verify this. We also can't verify any validation. So if we are using bean validation for HTTP post put to make sure an ISBN of a book is properly formatted, a unit test won't bring us far. Serialization, the same. So if we have like from JSON to JSON, have some more complex JSON setup, also impossible with unit testing without Spring. Headers, the same. So HTTP response headers, if we are doing anything there, impossible. Security we mentioned, and the same holds true if we take a look at other parts of our application. If we write a unit test for our repository interface, yeah, what do we want to do? There is no database, just in memory. We can't do much. We really need something else despite unit testing. And the solution that's, at least for Spring Boot, is sliced testing. So a typical application context, so our application when started, usually for most of the applications, I would say, looks similar like this. So we have the circles, the colored circles are Spring beans, so singleton instances of our classes. We have a web layer where our controllers are developed, so the requests come in. We have some util classes, which may be an add service, normal service classes that perform the business logic. And on the bottom, we have some data beans, so a repository that talks to Postgres, to MongoDB, or any other persistence layer. And they all work together during runtime, so Spring initiates them and they connect to all the external services. And when taking a look at this, it could be quite obvious that we can somehow separate our context into various parts. So there is a web part. So on top, the blue web layer beans, they could be grouped into a thing that can be tested in isolation, because when we test our controller, we don't care which native JPA query we are using when testing this in isolation. The same holds true when we test our database, or for example, our JPA mapping or a native Postgres query. When testing this in isolation, we don't care that the user comes in with JWT and key cloak authentication. Yeah, we don't care. And the cool thing that the Spring Boot team implemented is this concept of sliced context testing. So the annotations you see here, if we use them on our test classes, they will create an isolated application context. So not the entire thing, but only a slice. And for the slice, usually where it makes sense, so there's a web slice. There also, if you test HTTP clients, there's a slice to test your HTTP clients in isolation. And there are many annotations for testing various persistent logic in isolation. Because with this, we now can tackle, we will see in a second why this is a benefit when using the example of @webMVC test. So this annotation is used for testing our web layer in isolation, and it loads only the beans we need. And now comes the question, what beans do we need when testing the web layer? So we need the controller. We need, when it comes to HTTP, filters, converters. So if we have any filter chain before, or security configuration would be nice. Some controller advice, some exception handling code, for example, if you throw custom runtime exceptions that get mapped to HTTP response codes. This would be nice if it would be part of the context. And all of this is then scanned by Spring Boot. So with the component scan, Spring Boot knows which beans to look out for and then initiate for exactly testing this slice in isolation. In this example here, the customer controller test, when using the @webMVC test annotation, this comes with two modes. So we can either pass the name of the controller we want to test, then in the context there's only one controller. If we don't pass it, it will scan for all controllers. And the cool thing that now happens, so still where's the benefit of unit testing? In the background, Spring Test creates an instance of mock MVC. So mock MVC is both an environment and a client somehow. It has HTTP semantics. It's like in-memory Tomcat. It doesn't occupy a port, but it implements the HTTP servlet request. So this helps us to test HTTP semantics for the slice test. And we can also use it and inject it then into our test to communicate with our mocked servlet environment to fire requests that don't do HTTP communication locally over localhost, but direct calls against this mocked environment. And as this slice only is interested in the web layer, we have to define what to do with layers below. So if we do nothing, the context or the test will fail. It will say, you want to test the customer controller, but the customer controller depends on a customer service. I couldn't find it in the sliced context because you didn't ask me to create it. I didn't scan for it. Yeah, I don't give you the context. So what you can do, you can either provide real implementation of your service or your layer below. But usually you then cut at this layer and say, we're using Mockito to provide a mocked version inside the sliced test context. So like any layer below, we are not interested. We cut on the customer service layer and can test against the endpoint. To see this, so maybe the first thing that's quite interesting, what I did, I navigated into the @webMVC test annotation, and then you see this kind of big meta annotation. Stuff is going on, but here is, for example, the WebMVC type exclude filter. And if you go in here and scroll a bit down, this is now what Spring will search for in this sliced context. So types, Java beans of these types will be populated, so they will be tried to initiate. If for whatever reasons your filter depends on a repository, it will fail because it will try to create the filter, and to create it, it will need to inject all its dependencies. But here you can see it's quite a lot, but all relevant to our web layer to be tested. And yeah, nothing else compared to a service or a repository. There's one thing, there was a change some years before, or with recent or with more previous Spring Security versions, where we didn't implement a, show it, I want to talk about it. So recent Spring Security, you implement a bean of type security filter chain to then, in my sample application here, say any post request against customer needs the role user. Fibonacci is open for all, and the rest is authenticated. And we use HTTP basics, and we don't care about CSRF. So years ago, or if you also do the migration from Spring Boot 2 to 3, you will see this in action. Back then you had this extends web security configurer, something like this. So it was actually doing the same thing, but it was extending or implementing this class. And when you did this, this bean was automatically detected and put into the slice context. When going with this newer and I would say up-to-date setup for Spring Security, Spring needs to be, or we need to import it manually. We need to tell that Spring should include in the slice context, because we can also from the outside say, include this please, additionally to what you picked up from my application. We need to implicitly include the security configuration. Otherwise, I guess it's the Spring Boot security defaults, which you don't want to have because you want to check your real authorization, authentication. And with this setup, we now see a sample test. So customer controller, I mean, it's just a dummy CRUD endpoint, which does, which creates an entity and following REST best practices returns the 204 status and a location header where the client could then, request again to get to the created entity. And to write now a test for this, we could write a plain old unit test. So if we just use JUnit, Mockito, and an assertion library, there's really not much we can do. We can for sure call the public method, pass our payload. But if we would have, for example, here validated, during a unit test, you can pass just stuff from outside and the validation wouldn't be checked. Next is URI components builder. Then it already gets tricky when you try to mock framework classes. You end up in like searching for help. And last but not least, you get in this example a response entity where you could then verify that the header is present. But a much more better test here is the sliced test, because now with this mocked environment, you see here the request. It looks like HTTP. We are performing against API customers. We pass some JSON data, some content from the outside. So here nice Java text blocks where you can easily paste JSON. And then afterwards, we verify that the status code is 201, that the header is present and has our header in it. And the cool thing is, Spring Security has also a test dependency to interact with Spring Test. So here this with mock user. Let me run the test without. So I would expect the test to fail. So we have the security configuration that says you need to be of role user. Much noise. You can see here assertion. I got 401, but expected 201 because 401 unauthorized. I'm not authorized here. So with Spring Security, we can use. There are multiple ways to do this. With mock user is the most convenient one. For example, you can also then configure here the username. You can give this person some roles. So really like what it does in the background, it injects in the Spring Security context the user, like hard-coded in memory. There are also much more sophisticated things you could, for example, if you're doing JWT, you can also pass to this mock MVC request. There are some post processors where you can do passive JWT, where you can pass your authorities. So kind of like the user accesses your application, but somehow in a mocked fashion to test also your authorization. If I now put this annotation in here, we will see the test is green and could verify our endpoint. So this is also cool if you work with server-side rendered templates. So timely, for example, will be also rendered in the background, and you can check any views, that which view is rendered, do we get a redirect, and what's the data. So quite convenient. Okay, and these sliced context tests, there are many. Usually for all the persistence tools and for other GraphQL, Neo4j, you can even write your own. So for example, if you have a message listener, Kafka or something else, I guess there's no default implementation yet, you could write your own sliced context annotation. Check the docs for it. If you have a specific infrastructure component that is not used many often, but you see benefit, for example, message listener, you want the serialization to be tested a bit nicer than with a unit test. Yeah, this could be a way to do it. How many time do we have if pizza's here? Oh. How much time do we have? $20 is fine. Yeah. Okay. Cool. Then, yeah, this was slice testing with the example of web MVC tests. So with a database, it's a bit more complex because you need to provide a database. But yeah, check test containers, for example. And the other sliced context annotation works similar. The documentation is quite good if you want to check which are available, what do they populate. Yeah. What follows is integration testing. So also convenient thing that gets auto-generated for us is the single integration test with every new Spring Boot project that usually looks like this. At Spring Boot test, and then one test method that says context loads. So what this will now do, it will try to load the entire application context. So not only a slice, but everything. And when loading everything, we somehow have to define what's happening with our infrastructure resources. So we might connect to a message queue. We have some connections, some pooling open to a database. We do network communication to the neighbor team microservice REST endpoint. So all of this then needs to be provided for integration testing purposes and can get quite complicated the more integrations we have. And yeah, the less we have thought about this when implementing the first integration test. So when providing the entire context, what helps is test containers. So maybe who's not using test containers? Nobody, that's good. So I don't have to explain it. So with test containers, just 2 words. It's like a convenient testing library on top of the Docker Java API to manage the lifecycle of Docker containers for testing purposes. So everything that we can put into a Docker container, we can then use for testing purposes. This can be the message queue or the database. And we can use it for our integration tests to get closer or get as close as possible to production as possible, because we can also pick an H2 in-memory database, but this will also come quite soon to limits, because if we have any native proprietary Postgres feature, this can't be tested with an H2 in-memory database. This at Spring Boot test annotation comes with 2 modes. Like you saw it before, without any further configuration, this will not start Tomcat if we are using Tomcat, so no port will be occupied. And it will then, I guess, still use the mock MVC, mocked servlet environment. But if we want Tomcat to start and our integration test to really hit the application from outside, like users would over HTTP, we have to specify a random port. What usually makes sense, you can also say define port, but with random port, Spring starts it on an open ephemeral port. Otherwise, you get port conflicts if you start multiple contexts, and that's why random port makes sense. When it comes to mocking HTTP services, for example, during startup, you do a call to SAP or you fetch your the public keys of the OAuth 2 identity provider, something you do on startup. WireMock or mock server comes in handy. So these are stub web servers that you can instruct, similar to Mockito. For this endpoint, please return this response type with these headers and these response. So you can then fine-tune your network communication like you wish. You can then access this application if you don't use the port option with mock MVC. Otherwise, Spring Boot will auto-configure web test client and the test REST template. Web test client is the Webflux equivalent to the REST test template, and they are then configured against this. As you're running on a ephemeral port like 32,000 something, you can then get an HTTP client for testing purposes and can access your application and can test your endpoints. But then you can't any longer use it with mock user, because then you're doing real HTTP communication and you can't fake the authenticated user. You then have to provide either header or have to see how you get your JWT configuration right. So yeah, it gets a bit more complex than there if you hit the application from outside compared to mock MVC, where everything was like in memory and you could fake your logged in user. One of the hidden gems of Spring Test that I want to spend some more minutes on is the test context caching. So that's quite a nice feature that can help you speed up your builds. You get this feature out of the box, so all of your Spring Boot applications already use this feature. What it does, if you write a sliced test or an integration test, Spring Boot starts an application context for you. It loads the beans, starts everything, creates a connection pool against the database, and it will then cache the context. So a subsequent test might need the same configuration and then makes it super fast, because the context doesn't need to be recreated. So usual mid-sized projects, at least what I've seen, they take 30 to 40 seconds usually for starting up. Flyway does something, or Liquibase, then we check something somewhere. The connection pool Hikari gets loaded, and depending on your computer, it takes more and more time. And with the context caching feature, if a context can be reused, it's much more faster, because it's like in a matter of milliseconds, because an already started context will be picked out of the cache, and then the test will run against it. The size by default is 32, so can be configured. Least recently used strategy, so if you have to evict something from the cache, the least recently used context will be removed. I did many projects where we optimized for this feature particularly. This year's an example where we could get the build down from 26 minutes to 12 minutes, like all tests together, just by focusing on the context caching feature. How it works, a small example, like any other cache, if we have a sequential test execution, an order IT order integration test runs with a JUnit, requires an application context. Spring will check into the cache. Do we have a context started? I'm a new starter, nothing. Okay, start the context. The context will load, test containers will start the containers, do the health checks, Postgres is up and running. We are up and running, let's run the integration test. After the integration test finishes, the cache, the context is put into the cache. The next payment IT in this example starts. It has the same configuration. Spring Test will give this class the already cached context. No need to restart something with test containers. No need to see the Spring Boot banner again. It's super fast. And the last, if there's an IT integration test that has a different context configuration, we will see in a second where you can define if the context configuration is different. It will create a new one and then put a new context in the cache, growing up to 32 contexts, depending on the size of the project. And then, checking for each new test that is run. Do I have something in the cache? If I have a cache hit, otherwise cache miss, and I have to start a context. For the cache hits, it's important to understand how the cache key is built. So it's in the code is just a hash map, key and value. Value is the context, key is the cache key. And Spring needs to identify if a context configuration can be used for a subsequent integration test. So for example, if we have in one integration test, we use Mockito Bean for the payment service, and there's another integration test that uses the real version. Spring needs to create two contexts, because in the one context, one bean is mocked, whereas the other one requires I want a fresh, clean one, and I can't reuse it. So what Spring test does, it scans for a set of configuration parameters that define your application context. They are here, and if you change any of them, you usually have a context miss because something changes. So if you changed active profiles for your tests, one test is test-1, test-2, and you have different application properties or YAML files, Spring is not intelligent enough to look into your property files and see, okay, even though it's a different profile, you're not overriding something, but you could change timeouts, any other parameter, literally. So it's why it's quite strict and static what it analyzes. But if it's the same, lucky you, you get a context hit, cache it, and can reuse it. If you want to see this in your application live, so be aware if you have the Spring Boot banner still up and running, how often you see this. This is usually a good indicator that a new context got started and not reused. You can also see it by the timing. So with IntelliJ, it's sometimes a bit off how they report timing here. But in general, if you run multiple and see big differences in the execution time, it's usually an indicator something was cached, or here I need a new context. You can also enable logs to have more strict knowledge about your cache. So simply enable or add this logger, and then run all your tests, and then check the last test, and for this particular line of code, a line of log, and it will print out how big is the cache, how many hits we had, how many misses we have, and this then gives you a good indicator if you optimize for this, so you can reduce it and see in the data that you made it correct. Time's tight, so this is usually a game where I ask the audience where are any potential issues for context reuse, but you can see here the biggest issue flaw is dirty's context. So if you've used it, what it does, it literally says Spring test, don't cache it, please create a new context for subsequent tests, because I either modified global state or just copy-paste Stack Overflow. That's usually the two reasons. That's quite dangerous, but there are other issues. So mockbean, so the issue is if you change the setup between integration tests. If you do it the same for all, perfect, one context, one cache for you. But if you change it and do different things in different integration tests, you get a new one. So biggest thing, or the example you saw, what we had to refactor, we had an abstract integration test where this dirty's context annotation was living. And this made it super hard to make use of context caching, because somewhere, I don't know, 2 years ago, a developer couldn't figure out his integration test setup, copied this annotation, and then it lived there, and every subsequent test that was written was running and expecting a new context. But if you then remove it from the central class, you are stuck with some investigation time and then making your test suite afterwards happy when it comes to this caching feature. It's important how the context cache key is built. So if you're aware of this feature, if you know, okay, Mockito Bean and Spy Bean with different usages might not be the best, you have something to argue in your pull request review, for example. Monitoring is important, so you see the logs, you can let this run frequently. And then when it comes to the final numbers, there's also, I wouldn't optimize to say just one context for a mid-sized application. Sometimes you have good reasons to have different context setups because you're testing things. So it's the aim is not to reduce it to one, but to reduce it to a reasonable amount, and to like Pareto 80-20, see how it optimizes your build time, and how much more effort is required to reduce it even further. Quickly, some best practices. Test parallelization. So with the context caching, you can get quite far when it comes to reducing build times. Faster build times means faster feedback, developers more happy, you're not, yeah, you're faster at an outcome for your implemented thing. We can even improve this. We can parallelize our tests. So there are two ways, mainly for Maven, and I guess it's the same with Gradle, but I don't know the details. We can either tell our Surefire or Failsafe plugin to fork multiple VMs, so they can run multiple JVMs next to each other, and then can run isolated multiple tests, and then they are isolated. They don't share the context cache, but you have isolation. It's usually the simplest way to get started with parallelization. And the other way is to tell JUnit Jupyter, please, in my JVM that runs my tests, please spawn threads and then run in the thread pool the tests. And then you have same memory, but other issues, for example, if you have shared access to any resource and haven't optimized, for example, your database usage or your cleanup. So as you see here in the requirements, getting here, you shouldn't have shared state. All tests should clean up. So there's much more that goes into it, but usually try to start with forking the JVM and then see what happens, and use JUnit, for example, for the unit test as a first quick win. So it's a conference talk. I can't go that much into detail for your specific problem, but on a high level, this is usually what helps. So that's how it looks like. So blue side, Maven Surefire, you really get 2 JVMs, so you can check your operating system. It launches 2 JVMs. With JUnit Jupyter, it's thread-based, so it's the same JVM, but then within the JVM, multiple thread pools that share memory, and then share also the application context cache. Yeah. Get help from AI. One tool I would like to discuss. I guess we all of us play around with AI every now and then, and usually with the agents, or in the early beginnings, it was quite hard. So ChatGPT, write me a unit test, then you copy over, and then it doesn't compile. It uses the wrong JUnit version. So this was quite hard. Now with the agents, we are getting tools that are more aware of what we are doing. JetBrains Juni or Claude Code, which I'm using quite often. It gets much more better because they also then have access to your shell. So they can, for example, run unit tests, and then they iteratively see what I'm generating for you is not compiling at all. So yeah, I have to reiterate and not just print out what I think is a solution. One cool thing, or what I learned, is DivBlue. So it's a startup from the UK. It came out of Oxford, I guess. What they are doing is an AI agent to automate unit test creation for Java. They are using reinforcement learning. They come with a CLI and a IntelliJ plugin. And once installed, you get here a plus icon and instruct the tool to write me the unit test for my test class. What it will then do, it will analyze the code. It detects Java correctly. It detects Maven, what JUnit Jupyter version it has. Then it checks your controller. Are there any if-else? And then in the background, you see it's now working, which is quite cool because with all the assistants, also how to align this or unify within your team. So one developer has a different prompt and than the other developer. Then you have to align it and make sure all use the same. You can use instructions for the assistants, but having like tools that do this deterministically, also quite nice. It then prints out some code. I can accept this and then take a look at this. So just as an example, so this is also agnostic of Spring, which is cool because it helps to make it convenient. And super nice, for example, if you have a big legacy application that has no tests at all, so then you have a baseline, you can like freeze your code. You let this run once. They have a CLI, so it can also run on Jenkins. So you can also have some nice TDD approaches here. Yeah. What else? So Claude Code I mentioned. I'm using it every day. I think it's super nice. What I quickly want to show you, I guess it's super interesting. Yeah, after this, sure. Yeah, sure. So with Claude, you can define a Claude Markdown file and give him some instructions, which is quite interesting. So for example, you can tell him whenever you create code, please use this given when then, or will you use SRJ? So you can instruct it to behave similar. And what I learned from their docs, official docs, you can also use it to do TDD or to instruct it to do TDD. What I gave him as an instruction, you are a test-driven development workflow agent, and you need to develop the features that you are presenting or that I'm asking in a TDD fashion. And one example that I want to copy. So Claude Code is a CLI tool. You install it into your terminal, you connect it with API keys, and then you launch it inside your folder. And then I give him now an instruction, please develop TDD, a REST API that fetches stock information, so stock data from Apple or whatnot, and do it for me. So it will now reiterate, run, and the cool thing is it will understand what it needs to do. It will create a to-do list to sequentially develop the things. And the cool thing is it will first create the unit test. So unlike any other, you prompt in, give me the solution. You can prompt this to give me the solution TDD based. And then it starts with the first to-do, and it presents me what it would create now in the file system. So I can tell him I accept this or I don't accept this, and I can give him hints to say, for example, I don't like Java records because we are using Java 8, please adopt. And then it would reiterate. Or I can say, yeah, it works, or I say, no, it doesn't work. And I can also do the YOLO mode to say all future suggestions are auto-accepted. And then it will suggest it and auto-accept it, because this, I guess, a security feature. It asks you, can I run this Git command? Can I run this Maven command? But you can tell him, please ask me anytime, or you go full ham auto mode and go for it. And we don't have to finalize this, but I quickly wanted to show it to you. It does now all the thing in the background, run the Maven commands, and develop the feature for me, which is quite interesting. And with that, I'm done. Thank you very much. If there are any questions, or we've prioritized pizza and do questions.
I think if they can catch you over pizza.
Sorry?
If they can catch you over pizza, that would be great.
Yeah.
So ask questions there, if you have any, to any of the presenters. Okay, esas preguntas ahora. No, pizza. Yeah, let's go over pizza and we can continue chatting there. Yeah. Thank you very much.